Hi everyone. I think we are live now. I hope everyone can hear me well. Welcome to another community call. I'm Natalia from the DX team, and I know that of you who join regularly are not used to seeing me as a host, but Katarina couldn't make it today, so I hope I do her justice. Today with me, I have Carl, who is a senior software engineer at WithSecure and a PhD researcher at Alpha University. So thank you, Carl, for joining me. And before we dive in, I wanted to share some updates on GraphChat, one of Memgraph's standout features. So the latest release makes it even easier to customize how your LLMs interact with your graphs. You can now define custom context, tailor answers more precisely to your use case. So this is just one of the new features. We have much more. So I'll leave a link to the GraphChat documentation and the demo we recently created. So you can check that out after our webinar. And now on to today's guest. Today, Carl will demonstrate an agentic approach to building knowledge graphs from unstructured data. And he's leveraging LLMs and Memgraph vector search to do that. So Carl has developed a system for resolving entity resolution, which is a known struggle for many, including me. Before we begin, just a small note, we have a chat, so feel free to ask questions there. You can ask it either in the chat or the Q&A section, and Carl will answer those in the Q&A session at the end of the presentation. So we also have some of the posts posted, so feel free to cast your vote there as well. So that's it for me. I've been talking for too long now. I'll now step back and let Carl take the floor.
Mm. Thank you very much. Hello again, and I'll now share my screen. Yeah, okay. Hopefully you can see my screen.
Yeah,
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 and
okay.
so I'm here to present on the topic from chaos to context, where building knowledge graphs with AI agents and vector search. So, Iska, who am I? Currently a PhD student at Aalto University in Finland, in working in reputation systems and then knowledge representation, and also senior software engineer at, with Secure. And quite recently, as part of a team, we won the hackathon on the VTT challenge that involved entity disambiguation or entity resolution. So I would also dive into that the work that happened there. So that as there's a lot of connection there, and these are some of the team members, their names. So to dive into the topic, the chaos, so to speak, there is a universal problem where entities is tremendously difficult to disambiguate or to know how exactly if two entities are related or if they are actually one person in that sense. So this is an issue in organizations. We have customer records. Once there are abbreviations or there is an alias, it's difficult to actually connect it to that one entity. So certain analytical use cases cannot be performed. So it's highly chaotic, cause data quality issues, and it has been difficult to wrangle. Organizations have such valuable data, but to be able to actually decompose it into, or disambiguate it and then run analytics on it has been a challenge. So, and with the advent of LLMs, there has been multiple attempts because now unstructured data has hopefully been won, but still, because of the hallucination problems and stuff, it's still that data quality issue remains. So, I think there is a missing piece in that sense. So I think I alluded to the hackathon challenge. So VTT is Finland's premier research institute that collaborates with multiple both in industry and research organizations on like innovation or innovative solutions. So they are like a bridge between research and industry. And so they came up with this very interesting challenge called Beyond Names, where they had this entity resolution problem. They had innovations that had been published on their articles and then on their partners' articles. And they had done a lot of the pre-processing work where they had used LLMs to extract the actual innovations. Now they wanted to actually know if when two innovation texts or the descriptions were actually the same innovation and if they could be combined and resolved in a way that they could run analytics on. So in the sense, we have protein from air. Is it it's one innovation? Maybe on the partner website, it is something else. Solar Food discovers something. So they gave us this pre-processed data, and then they said, so can you build a pipeline, or is there a way? So this was the challenge, and that is what at least I would use to explain some of the processes that we took in solving this challenge in that sense. So during the hackathon, as we were developing, so you can see that before and then the after, we have these quote unquote innovation mentions on multiple partner websites when they make their press releases. New carbon food protein production process, solar food, protein from air by these organizations. Are they all actually the same entity? Then actually they are. And the whole point is once they can be linked canonically to as one entity, the next time an innovation like that comes, it's not going to create a new node in your database or in your graph. It's actually going to be linked as, oh, it's actually advanced protein synthesis, so that you can then have disambiguated nodes and then you can run analytics or whatever questions you'd like to interrogate the graph with. So during the hackathon, we developed this pipeline at a high level. So we wanted to take, so the VTT resource personnel, they actually did a good job of doing all the scraping and all the pre-processing for us, so that we had like the innovation mentions, but it was still chaotic in that sense. But they had done some pre-process, added some metadata to help. So that was our starting point, so that we didn't have to spend the whole weekend building scraping workflows. So you can break this down in two stages, three stages. One was we did some exploratory data analysis. We wanted to actually see if we could actually find the duplicates. So this similarity search is very good at this because it's text-based and structured text. So if you could find the similarity, and then at this step, we now wanted to see if there was an agentic way we could ingest into the graph without creating duplicates. So this pipeline enables us to achieve that, such that at the end we have a nirvana or an ideal set where we have a clean knowledge graph where there are unique entities and unique relationships without duplicates in the ideal world. And yes, so our attempt was to try and get to this ideal scenario. So the first stage, from the pre-processed data, we wanted to have duplicate candidates where we would have two pairs of concepts or two pairs of innovation, a pair of innovations that has got the similarity score of each. So we embed all the text and then run the similarity search so that we can find these duplicate candidates and rank them from the highest similarity score to the lowest, and then maybe filter or like filter it by a certain number so that we don't then going to the next thing, we don't take all that text. We just want to which of these are highly similar concepts. So this was the flow. We got the innovation mentions, we generated the vectors, calculated cosine similarity. And this was one key thing that improved our the similarity score, because just depending on cosine similarity might not be enough. So we added, because the data had rich context, like the domain of the partner website, the source document. So we attached all of this to the results so that we could then score it, boost the scores a little bit to help the next stage, as LLMs we know work better with more context, so that the less ambiguous, so that it does not hallucinate, so to speak. Then we go to the next stage, which so the output of that first stage now feeds into the agentic part. So now what we have is like an agentic flow that systematically tries to ingest into a knowledge graph, into Memgraph. So the idea here is that no duplicates at all. But how do we achieve this? So we achieve this by trying to ingest, making sure that there are no duplicates with the help of vector search. That, oh, are they in a similar nodes within this, and then based on the inputs as well from the previous stage, we make sure that those two candidates, are they the same concepts or they are different innovations? Then based on that, we also make certain decisions. So that is at a high level what is happening at this stage. And we have the specific tool calls that are behind the tools that are behind an MCP server so that at least they can be reused across board. We would see that in the demo stage. And then finally, a canonical knowledge graph after the agent has systematically gone through all the identified candidates. So we would actually see the graph. So this is just a representation. And now I would go to the demo stage to go through all the stages directly. Okay. So we're going to now run the first stage to get um, the duplicate candidates. So we have the ambiguity analysis. So let's see first what this script does. Hopefully, yeah. So this, it loads the original context. We embed, we use files for similarities, and then we use the context. So now running it, I have already cached some of the embeddings, so it's mainly going to focus on the similarity search, yeah, which is happening, finding duplicates. Yes. So we have the results. The total innovation mentions VTT, which was the main the research institute. This was the number of their involvement in all the innovations, and then the non-VTT. This also that is their partners. So this is mainly just some stats for exploratory data analysis because we also wanted to understand the data before we move to the next stage. Now, the first and then the second innovation here is where we have the duplicate candidates. And we can see here from the similarity and then the boosted score that based on just similarity search, these two concepts seem to be the same, but you cannot really know for sure because just depending on similarity score, just using this stage and then going to the graph, there will be significant amount of duplicates if you resolve them just like that. So this stage was very good to understand the data. But now, based on that, we now have at least an output to then feed into the next stage. Um, this is actually how the graph looks like after it has gone all the way to the clean canonical graph. But what I want to now do is to actually go to the next stage. Yes. Okay. So this is more of like a smaller test demo environment where I'll then show the graph starting from scratch, ingesting into the graph. So let me first remove everything. Okay. Then I'm going to ingest the organization. So the issue is not disambiguating the organizations. They help, they're giving us some metadata to then be able to like know the organizations using their VAT IDs. So I'm going to just then, okay. So now we have the candidates. So what I'm doing here is loading in the organizations because it's organizations that are linked to innovations. So we now have like organizations for like just a small subset. So now we can then now run the agentic the agentic aspect, which will then ingest into the graph gradually. Okay. So it's starting. This was all but for this demo. I'm just going to go through 20 so that we actually see what is happening in terms of what the agent is deciding to do behind the scenes. So, so if you can see the bottom, I'll try and then make it slightly. You can see it's starting with resolve or create organization, which is a tool that I have, to then that will do vector search, and then so it has made a decision in that sense that these two innovations are actually the same, and it has made a decision into the graph. So if we run the graph, we just emptied it, we can see that it has actually linked all of these organizations to this innovation, and with some certain attributes and certain information on them, including their mentions, where it was mentioned in that sense. So if you continue, it's doing the next duplicate candidate, and so on and so forth until the graph is rich. It's rich, but it's happening sequentially because it needs to do a positive feedback loop. It needs to do because for the resolutions get better with each resolution because it leverages vector search by searching with the existing graph if there are similarities, and then decides based on the context that we've provided. So as this is going on, we can this is the full graph that after I let it run on all the data. It's because it's a sequential process, it can take quite a while, but we can immediately see that the VTT, they are at least they seem to be this at the center of a lot of innovation just based on the data by looking at the graph. There are interesting things, but then we can, now that we have this graph like this, we can then run interesting graph analytics, page rank, community detection between us, and all the interesting graph algorithms that at least we have. And one interesting thing too is I have made it, since it's an MCP server, we have access to the tools here to then ask or interrogate the graph in any way that we like. So let's say find two innovations, or find an innovation and give me its a timeline or something. Yeah. So it makes a tool call, which would then, based on how, would then get the information that it needs. Then on the next stage, it's asking to make another tool call to get the innovation timeline, since that is how the graph is being populated. So based on that, we've been able to interrogate the graph and then gotten details directly from this graph that we have here. Yeah. So these are the tools that are being used to interrogate make the entity disambiguation, and then we have the tools to do this and graph analytics. The agent doesn't actually do the analytics; it's mainly focused on one stage, and then the human element or the human aspect is focused on the last mile, which is where there are duplicates because it's still not a perfect system, and then the analytics part. So these are the tools that are made available. So you can see from here, you notice some of them are off. Analyze innovation ecosystem for one, and then merging entities, which are only human specific tools that would bring in that nuance. Okay, so what makes this possible is the having the ability to run vector search directly on the graph, and then once you have the results immediately, you can then use that results to make further decisions with context by the agents as it's being run in that systematic manner. And then secondly, we are keeping an audit trail of all the decisions that are being made, or and then the context. So once we have the innovation mention on the relationship, the next time it pulls in a similar innovation node, it pulls in all the mentions as well. So it can figure out that, oh, these two innovations are actually the same. I don't need to create a new innovation node. So this is the agentic reasoning coming into play to make sure that all the innovations is one canonical node and then multiple mentions so that it can keep all the provenance, so to speak. So from the results, you saw how VTT had center stage in the whole graph. So it's also highlighted here. It was VTT, and then the partners were spread out across innovations. So some technical highlights in that sense, like I highlighted, the vector search directly unified in the Memgraph space really helped in that sense, so that there's no context switching around. And then for the innovation nodes, deterministic IDs really help prevent duplication and allow for new evidence. MCP also helps to build that interface so that we can then have human in the loop elements, analytic elements, and then the entity resolution elements all on the same code base so that we don't do double work or triple work. And the positive feedback loop that I mentioned, someone would ask, oh, why wouldn't you batch the candidates so that it's faster? But the idea is once a resolution takes place, the next one would benefit from the previous resolutions to then make it's like a flywheel. It gets better with more resolutions. So some of the insights that we got was that context really helped. If we had just used pure semantic similarity to go to the next agentic stage, there will be so much ambiguity that it will be garbage in, garbage out. The model would not have enough context to make the right resolution decision. So there will still be different nodes, which mean the same concept. And the agentic approach really works here because there are certain multiple decisions are being made, as you saw from that CLI. It's first had to resolve, then add mention to a link, and all of these. They are multi-step, so it's agentic solutions really shine here and highlight the graph and vector as a one mental frame. It's very good for these type of tasks. So what's next? So it's mainly more research exploration, especially for the graph algorithms that can now be run as a result of if you have a canonical graph where you don't have data quality issues. What could you discover? What questions could you ask that could be answered that traditional databases couldn't ask? Since it's more intuitive, it's a graph model that humans can understand, and the data is it's very domain agnostic because there's chaos everywhere. There's unstructured data. We know that there's signal in the noise, but you first have to extract this signal uh, and then build an agentic way to then build a graph that we can then now interrogate. So yeah, so this was it's at a high level what I had, and thank you for your time and then attention. We can go back to the graph to see if it has um, actually added more stuff or less. Let's see. Yes, so we can see we've been adding more nodes, the innovation nodes, and then the organization nodes, and it's still running and making decisions. And when we go to the data, we are keeping track of all the decisions that is being made and the reasoning behind it. So it's saying both mention the same core innovation. So that we can then have an audit trail and then try and understand a new decision just came. So yes, this was my presentation, and hopefully I wasn't too fast. But thank you very much.
Yeah, no, you're great, Carl. Thank you. This was amazing. You've had an amazing presentation and demo. It was great to see your code like live in action with Memgraph. So yeah, And the live demo gods were in your favor this time, which is rare to see. But yeah, we have a question from Mikhail. So he's wondering where we could find the script you're running. Would you be able to provide any GitHub links to that?
Yes, I can provide some GitHub links from it's mainly the hackathon code that is
Awesome.
available. So
Yeah, so we have an on-demand page. I'm going to link that to you. So after this event is over, we're going to have our presentation at that page. So feel free. Oh yeah, Carla just sent it. Awesome. So in case you're not watching live, feel free to keep track of that page, and we'll link all of the code there as well. So yeah, if you have any other questions, feel free to post it in the meantime. But maybe I have one question. So in your project, you're utilizing Memgraph vector search to help resolve your entity resolution issue. So did you stumble upon any technical challenges in leveraging vector search?
Y- Yes, it's initially when I was exploring it, you know how the dimensions of the embeddings, I was trying to find the right one. So I was initially experimenting with a different size, then I would increase it. But I realized that MemGraph didn't really like that. So I had to like remove everything again and start from scratch with with a consistent embedding size because I couldn't later export the graphs to maybe to share with my team members. So that was one particular hiccup that I faced. So like
Mm.
you would have to start and be consistent with a specific like embedding dimension, so to speak.
Yeah, did you find some kind of a sweet spot when it comes to dimension?
Just it's was specific to the embedding model that we use for the hackathon. We used the text embedding the open from OpenAI, but then
Mhm.
maybe when I'm playing with it, I don't have access to that anymore. So I wanted to use some of the Olama ones, the Olama models. Then so it changes depending on what I'm actually using. Yeah.
Yeah, yeah, makes sense. And we have another question from Henry. So, what is the average time for decision from an agent?
Okay. So the average time for decision is a minute, 30 seconds to a minute. Yes. So if you can see, yes. So for
Mhm.
I think for over I think 3,000, it finished. I left it overnight on the Saturday and then Sunday, we were then able to present for the hackathon. So it was tight, but I couldn't batch it because the quality would immediately go down if I use
Yeah,
the batch.
makes sense. And what is the largest data set that you have disambiguated or graph size?
So so far it has been in the thousands. I've not gone into the tens of thousands. Yeah, I've not, or
Yeah.
even the hundreds of thousands. And yeah, it's and always the relationships tend to be more than the actual nodes, since it's doing that, how do you call it, dimensions and at least dimensions
Mhm.
concepts, adding to that
Yeah,
mesh.
that's actually a lot of data for LLM calls. So
Yeah,
yeah, thankfully
exactly.
it worked out well for you.
Yeah.
And yeah, one more question from the same user, Henry. So, do you find different challenges distributing homogeneous versus heterogeneous graph models?
Homogeneous versus heterogeneous.
I assume Henry is referring to like if you have all the same labels in the graph,
Mhm.
or if you have a lot of the different properties and labels.
Okay. No, it's more about how you design maybe the prompting. If you make it few short as well, and you detail the graph model and with at least few shots and examples of how it should do the entity resolution, it's able to figure it out in the models. And you also use a capable enough model. We noticed that with more context, the models were able to actually do the disambiguation better. Yeah, but with less, or with less and then a less capable model, it fails basically. Yeah. So you also have to do some evaluation here on the quality.
Yeah, yeah, makes sense. Yeah. I hope that answered Henry's questions. But yeah, I'm sure you're now full of experience in this area and have many advices after hackathon. So What advice would you give to an organization that is trying to implement a simple or similar entity disambiguation pipeline?
Yeah. One thing that I really appreciated was, at least during the hackathon period, was that we were given pre-processed data where at least we had context. Although it was so chaotic, it was linked to context, the source URL, like certain metadata. That's even after the similarity, doing fast similarity search, and everything, we could still link back this metadata so that the duplicates that we are sending to the agents would be rich. It was tremendously valuable. So one thing I would like to say is that this pre-processing step, this data quality step, is very helpful. So that because an agent is not going to be the full solution on its own, and then like a pure traditional approach is not going to be the full solution. So it's a merging of the two, and then the human in the loop at the last step to then find the ones that slip through the cracks. It's a multi-pronged
Yeah,
approach. That's when you would get success in this.
I
That's it.
think that's usually the main advice. But with anything that comes to like working with LLMs and AI,
Mhm.
so you always have to have the human in the loop.
Exactly.
So LLMs are not that
Mhm.
advanced yet.
Yeah, yeah.
But yeah, I see that you have a quite advanced project or hackathon, and you mentioned like working or waiting for your results to process from Saturday to
Mhm.
Sunday. So that must be
Yeah.
nerve-wracking.
Yes,
Do you
exactly.
have any prizes during your VPP hackathon project, or everything
Oh,
went smoothly?
yeah. Yeah, the real surprise was that it worked at all. Initially, because with prompt engineering, you would try it, and the idea that you would actually go to bed and then you'd wake up and it would be you'd have a graph
Did you
was
sleep
new.
at all that night?
Yeah, or you'd wake up and then something would fail. Yeah, you wouldn't know. So yeah, that was it.
Yeah, yeah,
Yeah, one insight that we also got was mainly that context part. Usually, we are all, oh, we just embed it and then do similarity search. Then you would then have good results to feed into the LLM. I realized it doesn't really like work because the context will improve the quality significantly. The metadata attached to also boost the scores of the similarity score was really, really helpful. So like metadata is king. It gives and
yeah.
then you can also go back and do audits that, oh, it actually made a decision because it had this context instead of just a similarity score. So that was these 2 points were the big surprise that at least and takeaways.
Yeah, I'm glad everything worked out well for you at the end. Yeah, great job. I think that's it. Oh no, we have one more question from Wade. So he said this was really interesting to see. Curious about your thoughts or lessons learned contrasting with more traditional GNN and link prediction approaches.
Yeah, so the more traditional ML approaches would, because of the edge cases, it's because, and also the retraining step and all of these, the machinery behind it versus this agentic approach, which is like human grokkable. It's about prompt engineering and like architecting it in a way that you can have an audit trail so that you can see the reasoning. Although Genius also have an explainability component to it, but with the agent, if it's designed to also leave behind a decision trail, you can then go back and then fix some of these elements. So I still think that this one wins. It opens up at least who can contribute and who can at least help to make the at least the actual outputs, the quality continue to remain at a high level. So I think this is how I would answer that.
Yeah, awesome. Makes sense. Yeah, I think that's all for the questions. Yeah. So thank you, Carl, for your presentation. Thank you for answering all of our questions. And yeah, this is really useful to me, and I hope it was useful to everyone else as well, and that you enjoyed the presentation. I guess I see you on our next call, and I hope everyone has a great rest of the day. Thank you, Carl, again.
Thank you
Bye
very
bye.
much.